See my screen.
Yes, sir.
You can't see my screen right now.
Yes, yes, sir.
Yes, sir. We can all see. We can. I can see it.
Okay, let's start. Can you see the software now? Can you see the screen?
Yes, I can. We can. I can see it. But your, I think
Yes, sir.
your voice is cracking somehow. Yes.
I think it's the network. Can
Okay.
you hear me clearly? Can you hear me clearly now?
Yes, sir.
Yes, sir.
You can virtually low.
Okay, I said in the last class that today we are going to do introduction to the modeling, converting our sketches to 3D. And the first two we are going to explain is extruded boss. I said before every tool here in SolidWorks, as you are clicking on it, as you have your mouse on it, it's going to show you a preview of what it's doing. That's one thing you need to take note. So that's to help you know what you are going to do by using the tool. So let's start with extruded boss now. If you are not hearing me, let me know. I'm about to go back again, explaining what I've explained before. So to start a 3D sketch and a 3D model now, you know that the origin is you need to start a sketch first. If without a sketch, you can't convert anything to 3D because there's nothing for you to convert. So I can either decide to start my sketch without to start it on the front plane. I can click it on the front plane to show me option for sketch. I can just choose the sketch and start it. After that, I can draw my sketch like this. After drawing my sketch, I can just click on everything. After finishing my sketch, that means I will have to go and click on extruded boss itself. Recognizes the sketch. To click on the extruded boss. How to do the extruded boss. Everything will be done manually. That's the way. But it takes time that way. So I want to delete this sketch now. I'm deleting this sketch. So I will start with extruded boss by clicking on this extruded boss and not clicking on sketch. Or another way is that I can click on this sketch tool. Still the same thing like clicking on front plane. I'll click on sketch tool. So this is like the longest way here. So after clicking on the sketch to prompt you to click on front plane. And you take it to front plane, start your sketch. After doing the sketch, then you go and click on the edit tool that you want to use. But that one is also a long method. But I can just go ahead and click on this extruded boss. Click on the front plane directly. So automatically it takes me to the sketch environment. Already switch the tab to the sketch environment. So this exit sketch is meant to exit your sketch after you've done it finish. So after exiting the sketch, it won't take you back home. It will take you immediately to the 3D that I clicked on before. So that one takes time. And you are working on that pressure. So after clicking on the sketch box, I click on the sketch. I said you want to explain extruded boss here. I'll be doing different type of sketches that I can use to properly explain extruded boss for you guys. But the first one that I will make mention of is the blind option of extruded boss. So I'll just draw a rectangle for that. The corner rectangle. I'm clicking on the exit sketch tool. I can click on that one, or I can click on the exit sketch here. It's still the same thing. Both of them will do the same thing. I'm going to the blind tool now. So the first type of option in this extruded boss or boss extrude is the blind option. Lots of options here. This one, there are some other options that are supposed to be here, but due to what I've done, those options are not valid, so you won't see them here. Since I know them, I will create that enabling environment for it so that we can see the option. I'll be able to teach you guys the option. So the first one here is the blind option. The blind option is just meant for you to specify a depth. And you see, the first one is which direction is it going to go, but it's still the same direction. No special direction here. It's just going either like this, or I can click on this arrow to reverse it. It goes to the other way, and I can reverse it back with this arrow to go here. I can specify the dimension here. This is the depth. So depth, I'm using the depth to specify dimension. So I can increase this dimension to I'm increasing it to 50 mm. Easy, it increased. So this draft is meant to specify a draft angle. Draft angle is meant to maybe you want to shrink it or expand it. So click on the draft now. So what draft does is it drafts it inward or drafts it outward. So I can specify an angle here, maybe 15 degrees. Let's see. Instead of going straight in a straight manner, if it's going in a 15-degree dimension, I will do something now. I want to teach you guys something before the end of last class, but I forgot. So I will make mention of it now. We forgot to take sketch block. There's only one sketch block in SolidWorks. We're supposed to take it under 2D sketching. The sketch block I forgot. So I didn't really do this in Google. But I will explain it today. After explaining all the extruded boss finish, I will make mention of sketch block. I'll show you a demonstration. Then we'll move to revolve boss. So I'm explaining this draft tool now. I draft it by an angle of 15 degrees. So it is going inward. It is still the same depth of 15 millimeter, but it is not going in a 90-degree way. I can click on to make things fast instead of clicking on your view here, on the view orientation here. You don't need it. The short cut here. To have a top view now, you can just to have a top view, you can click on your control key and click on 5. You have a top view. So you are looking it from the top now. You are looking it from the top. You see that when we then click on the draft, I'm going to uncheck the draft option now. So after unchecking the draft option, you can notice that it is going in a 90 degree. But if I check it back again, if it changes, that means it is going inward in 15 degree. That means the angle is with respect to the horizontal. So if I increase it, you notice that it bends once again. it bends. Can you see it bends inward again? So you notice that what draft does is it drafts it in all angles. So after clicking on the top view to view the top now, we are viewing the top here. So I can click on Control 1, which is the front view. Can you see? It has already drafts it. Because if I want to check my draft option now, it's still the same thing because it's going in 90 degrees, so we can't see the inner part. So I can check it back again. Can you see this is the front view? Control 1 is for front view. Let me quickly make mention of that. Can you guys hear me? It's not like I'm just talking without receiving the feedback.
You can manage, yeah. We can hear you.
Okay, you can hear me. You are seeing my screen.
Yes, sir.
Okay, that's good.
Yes, sir.
Someone said something. Let me. I ask you the question. Okay, let's continue. So control 1 is for to have a front view. Control 2 is for back view. Control 2, control 2 is back view. Control 1 is front view. Can you see? Control 2 is back view. Control 3 is left view. Control 4 is right view. I know you are getting what I'm doing. Control 4 is right view. Can you see? Along all those views, it's still the same.
Yes, sir.
The angle is 15 degrees. Control 4 is right view. Control 3 is left view. If you are following me, Control 5 is top view, like I said before. Control 6 is bottom view. Control, that means you click on your control and click on 7. That one is isometric view. That one is you are viewing it in 3D. So that one is for isometric view. And like control 8 is like alternate view. It's maybe you are pointing in front view now, you are control 1 front view now. Instead of clicking on control 2 for back view, you can click on control 8. It will go in the reverse direction to take it to back view. So we are on control 5 now, which is top view. So clicking on control 6 bottom view. Just click on control 8. It will take you back to the front view. It will take you control 8 to take you to the back. Control 8 once again to that. So you just alternate between front view and back view for control 8. So that's the one for control 8. That's what control 8 does. So that's just to explain the control we have, the shortcut for switching between all those views in while sketching or while doing anything, any modeling that are doing. And like I said before, the draft is meant to shrink it inward. And I can check this draft option to do what? To shrink it outward. Because all these two you are seeing here, it depends on your understanding of them. You can do any type of structure, you can do it based on as long as you understand how all those things work, you understand all those options very well, you mastered it, you facilitate it, you can use it to do things that someone might not even imagine. It's as simple as this. I'm just teaching you guys this is how this one does, this is how this one does. You might not really know how to use it very well until you start applying it. So that's when I start plugging some 3D and model. Like it will be with dimensions. I guys you have to go and model it for me based on what I've taught you guys. I will not draw something that I haven't taught you guys. So today we should be able to finish just revolve boss and extruded boss. We will treat all the options finish. We'll make sure we treat on that very well. So by the end of this, I want us to finish all the options on 3D. So this is draft outward. So it is going outward. So I can check this direction too. What direction two does is we want it to extrude in both ways. So I can decide that I'm drafting down to outward in the direction two from that middle, and I can decide to increase it to 50 millimeter. Enter. Can you see it increases? So I can draft it inward. Can you see I'm drafting it inward? It will just be like a tower. something like a full like that. You can even use that concept to design something else again. So that's direction two. That means I want to make it go in both ways. That's how to make it go in both. That's why I'm checking the direction two. The same option for direction one and two is the same thing that is in direction two based on the available condition. So what I'm going to uncheck this direction two now so that I don't want it to go in the other direction. So what thin fissure does this? It actually can you see what it does? It takes it out. But the first thing I have to do is let me show you the extruded boss by explaining fissure. So you see after explaining this blind option now and the draft, what that does is it just shrinks it. I'm extruding it outward now, so it expands. But it is something like it tapers. If you can understand what tapers means, like it tapers, the distance starts changing. The how slant it becomes slant as it expands. As it increases in thickness, it becomes slant. That is not going in a, let's say, in a linear way, or let's say in a linear way, it's going in a slant way, not going in a linear way. Or should I use that word? I'm going to uncheck this draft option now because I still want to see you guys another option in the blind too. I'm unchecking this. Now let me come back to normal. Like it's going in 90 degree. So 90 degree to the sketch plane where I did the game. The sketch plane. And this one is going in 90 degree way to the sketch plane. So the second option here is up to vertex, up to surface, offset from surface, up to body, but we don't really have something to demonstrate all these ones here. So I won't do anything on this for now. I want to explain midplane. What midplane does is midplane works like you want to draw your midpoint line. While I was teaching you guys with this question, you want to draw midpoint line now. If it's a normal line, you're just starting from one end to the other end. You move your arrow to the other end. For midpoint line, you're just starting where you are starting, and you are moving it to the other end. It is also increasing in the same proportion or dimension. It's increasing in the same length in the other end too, without you having to move your mouse to the other end. So you are just moving it in one end and it is going in the same proportion to the other end. What midplane just does is it takes out this 50 mm, it takes it and split it into two. It started from the sketch plane and it is going in 25 in both ways. It is going in 25 way in the first way, 25 in the second one. That is for midplane option. So you can edit it, increase it to 60, however you want. So I want to use that to explain mid-plane option. So I've explained mid-plane option. Now let's take it back to the line and let's check. Let's put on our grain check. So we have our first process food here now. Can you see? We have our process food. Can you see? So what I'm going to do next is I'm going back to this feature here that I just did. I'm right clicking on it and I'm clicking on the feature and I can hide it too. Some options you can find here. You can hide it. I'm not saying it again. I can right click it again and click on show. Another thing, showing back. So I'm right clicking on it again and I'm clicking on. I'm not editing the sketch. I can try to edit the sketch. That's the base something. So as I'm editing the sketch, I can change the dimension and it will update. But I'm not editing the sketch. I have to edit the feature. What we are seeing is still the one talking about today. I'm not dealing with sketch. So edit the feature now. I made mention of blend before. I want to use this opportunity to explain the feature now. Okay. The there is I should have explained it while I was doing it before. Normally, the thing feature would have been would automatically disappear if you want to edit it. You can't see the same feature there again. So let me just redo, let me delete the feature and redo the extruded boss again. Let me delete this feature. So I'm deleting it. So to redo my extruded boss again. So if you do extruded boss now, let's assume you have a predefined sketch now. We have a predefined sketch. So to redo your feature, instead of clicking on this and still having to click on the sketch again, just click on this sketch, you can pre-select it however you want. There are different ways. So you just click on the extruded boss now. So it automatically recognizes it. So those things saves your time. Teaching ways to save time. So can you see now the same picture is back again because I want to create it from scratch. I'm being extruded boss, but I want to click on the same feature. I'm checking the same feature now. What the feature does is it just it can make it plain. Can you see? What the feature does is it works like this. It takes can you see it takes sketch here and it extrudes it. It fills the inner part. So I made it mid-plane. And it goes in both ways. But if I make it one direction now, I see it does good. Let me click on control one. You can have a front view. I can better understand what you are saying. Control one, yes, you can understand it now. So previous what it does is it does take it in one direction by 10 mm. I can reduce the thickness to 5 mm. So 5 mm now. So that's what TV does. It takes it upward now. And I can set that one direction to be downward. Right? It's going downward. After clicking on this arrow, anywhere you see this arrow, it usually exists in a lot of features in SolidWorks. Anywhere you see this arrow here, it plays direction. So you can just stop it. After clicking on it, it changes, it updates, it goes in the other direction, and it goes here now. So can you see? So that's one direction. I can make it go in two direction now. You see, it is going in two direction. But that's the direction. The second direction, can you see it is thicker downward and it is thinner upward. So because this one is 10 mm and the first one is 5 mm, so you can also reduce this one back to 5 mm. It is 5 mm now. So I'm making it go in two direction. I can make it to just go mid-plane. What mid-plane does is it takes that 5 mm. Like I said before, mid-plane extrusion in the normal option here. It splits that 5 mm into two and divides it into 2.5 upward, 2.5 downward. That's what feature. And we check it now. You see what the feature does now. Can you see? Actually, it is it out. That means it's just excluding the sketch alone. That's what the feature does. Its work is actually similar to an extruded surface in surface modeling. It's similar to it, but it has thickness. Unlike extruded surface, that one has zero thickness. So that's what the surface tool does for normal surface tool. But we are talking about 3D normal features tool here. So that's a student thing. You can notice that it's showing me that it's a student thing. That is, it is not a student boss. Like another feature on its own. So I have to click on it now. I can edit it back to the normal one now. Or is it possible for me to uncheck the same feature? Let me see. It is possible to uncheck the things I've done before. It's not possible. I see it is already grayed out here, so I can't uncheck it. What I can just do is edit this normal blind option here. I can start changing it. I can change it to mid plane now. Can you see what I'm doing? It's mid plane. I've explained the feature. So if you don't understand it, please let me know before I move to the other options under Extruded Boss. So we've explained the blind option, the mid plane option too. So while I explain the blind option and mid plane option, we need to explain the first part, the upper part there. Let me delete the 15 feature now and explain it once again. So I'm clicking on selecting this sketch now. So I'm going to click on Extruded Boss. After clicking on Extruded Boss now, this first option here that says that was I said that I need response. I can know those that are following. Can you see my screen?
Yes, sir.
Okay.
Yes.
Can you hear me?
Sir, yes, sir.
Okay. Can you hear me?
Yes, sir.
Okay.
Yes.
I'm explaining this extruded boss, like I said before. Also explain this first option here. It says I can normally the sketch screen is front me.
Yes.
It from sketch screen. That's the sketch screen where I sketched my 2D sketch. So I can decide not to extrude it from there, and I can extrude it from using an offset. So initially it is 0 millimeter. What offset just does is it moves something away from the initial position. If you are just offsetting by 0 millimeter, it's still like it is in the initial position. So nothing is changing. So we are going to offset it by 10 millimeter now. That is it moves from the original sketch area. It moves from the original sketch area. So I'm offsetting by 10 millimeter. I can decide to change the offset backward. Can you see it is offsetting from 10 millimeter backward? You can notice that it is like it is starting from the back, not from the front. Try to get the difference between the two. So offsetting it from 10 millimeter backward. You understand me very well. It is offsetting it from 10 millimeter backward. So that's the offset. So then another option here, we also have offset from surface to here. But there's no surface we want to offset it from here. So we will use another thing to explain that. So that's what offset just does on its own. So I'm offsetting it by 50 mm. I can change the direction of the offset now. Can you see? I can try to choose surface, face, or plane. So surface, face, or plane now. Is asking for a surface, face, or plane. Let me do something funny here. Can you see? I'm still using the same front plane again. But this one usually helps in another scenario. I'll create a scenario for it. Don't worry. So I'll still explain. I see a lot of options here that I'm not showing here. The reason why they are not showing is because those things they usually determine what is currently there on this graphics window, and that's how it pops up the option. So there's a particular option there that is up to next, but it's also not there because it's another thing entirely. That's the openness feature. That one is another thing entirely. So I'll create a scenario for it now. So you just have to give me time. I want to create a scenario for this up to vertex, up to surface, up to vertex and surface, up to body, mid plane. Not mid plane, I'm blind now. So I want to do something. I want to create the sketch now. So I want to create the sketch now. I will edit this sketch. Again on my circle tool. Now dimension. Let's use the dimension for this 115. So I'm using the dimension for this 140 mm. Going for this. So I'm clicking on this. So I'm clicking on this now. So I'm clicking on this gauge to extrude something upward. I'm extruding it upwards. So sorry for the normal extrude. I can just do the normal extrude of maybe 1 mm. I can edit the sketch. So and edit it to be let's say 125. 125 is okay. For 120. Sorry for the delay. So first thing I want to do is that message to switch always on mic. I want to create maybe something like an extruded boss now. I want to create an extruded boss on this. So extruded boss. See, that's where your offset entity that I made mention of will be very important. So I'm offsetting this and also convert entity. And it's what I'm doing now, converting this to an entity, to a sketch entity. I now have to start drawing the sketch by myself again. I'm offsetting it again without drawing any circle. I'm just using the normal tool. Offsetting it by 10 mm outward. Can you see? Yeah. So I'm done. I want to extrude it. And you see it is going upward. So I'm changing it downward. Now let's start with the first thing that I want to make mention of. So what drawing does is you specify dimension, right? But still, however, you can do a lot of sketch, doing a lot of drawing scenes, and we don't even have time to start remembering that you first did a student goals for the first one. You didn't even remember the dimension. So instead of to start going back again, I've forgotten the dimension, you don't need that. All you just need to do is up to surface. That's where the option is here. What up to surface does is remember everything remains blank back because we haven't specified its surface where it's going. Can you see up to surface? Can you see what it does? It extrudes it up to that end. That's what up to surface does. It specifies the surface to extrude it up to. That's what it does. So another thing it does now is that's the first option up to surface. The direction of a thing, I'll teach you how it is being done too. That's another thing. So up to surface, that's it. So I decided to say I'm not using my sketch plane. The first option here, like I said, I'm offsetting it. Offset it by 10 mm. And let's say top view here, or a front view. Front view. And you see, I'm offsetting it by 10 mm. So it is starting, it is going above board. It is going above this upward. How to change the direction of the offset now? Can you see? It is going away from that face. It is going away from that face. So remember, the first thing I did is, before doing this extrude is, I sketched on the face. You can sketch on the face and SolidWorks. It's not only on the plane. You can sketch on the face. You can sketch on the plane. You can create a plane. That's what I'll cover to you. You can create an artificial plane yourself. That one is very important. When you are doing some complex sketches, you start creating a artificial plane defined by some boundary conditions. So you make it, before you create the plane, it has to be fully defined and stuff like that. So I said offset, we are offsetting by 10 mm. Now, because we clicked on up to surface, so we click on this surface. So from that place, by moving it downward by 10 mm, it will start from here. After it moves down by 10 mm, it starts from that point, start 10 mm from the initial surface here. So it starts from here, this 10 mm side, and go to this surface. But we are not doing that now. We are choosing another option. It is called offset from surface. So what offset from surface does is, it specifies that you click on a surface. Which surface am I offsetting it from? Clearing it, clicking it again for you guys to see. I'm offsetting it from here. But can you see? Normally, what I did when I did the initial offset was 200. So I'm offsetting it from that surface of 200 now. The extruded boss, the first extruded boss I did was from here. And I extruded it by 200 up to here. And one thing about SolidWorks is that after you did, because I did a 200 mm extrusion before, it's automatically bringing that 200 mm extrusion back for me, because that's the previous thing I've done before. So it is freeing me back. So I need to take note of that again. So now to reuse it, I'll just reuse it or edit it. So I take out to surface, and it is saying offset from surface by 200 mm. And I know what I mean, because you are offsetting it from this surface by 200 mm. It is going, like it is going upward. Like it is going, you are offsetting it, you are starting by 200 m here. But if I'm changing the direction now, direction of this offset to here, can you see what it is doing? You can see what I did now. So it started the offset from the other side. After starting the offset from the other side, it is offsetting it by 200 mm. But let's use this first side. You need to understand it now. Let me reduce it, not by 200 mm. Let's make it 15 mm.
I can't see your screen, sir.
Let me join again. Let me check. Okay, the network.
Okay, sir.
As we share it again. Before we switch it, last month we doing it again. When it ends, to take notes. So if it ends, I will send the link back. So that is it. Thank you, Mr. Football. Is there with me is the network. Can you see my screen now? Can you see it now?
Yes, sir.
Okay. So let me explain it. Like I said before, I use this expression. I said offset from surface. I already use that surface. So I want to reduce it to 50 mm. What that 50 mm does is, from this surface, normally an edit initially that don't extrude this thing from the initial face I do the sketch, extrude it from there. Take it further. Start from 10 millimeter further after that face. So it will obey me. Starting from 10 millimeter. After I move 10 millimeter downwards, so it's starting from here. So you are now going now. You need to offset it from a particular surface. So what's the surface? This downward surface. I click on it. By what millimeter? So I set by 50 millimeter to this side. So it is by 50 millimeter now. I'm telling it that if you are offsetting it from surface by 50 millimeter, it is going to offset upward, like it is increasing. That 50 millimeter is increasing upward here. It's increasing like this. So it is going upward. So if I use it 40 millimeter now, it goes downward because I've reduced the offset from that. So it is actually offsetting from this surface. This is the end condition. The end condition here. So it is telling me that I'm usually going from to this end, this face, but I need to be offsetting it from this face by what millimeter, by 40 millimeter. If I want to this face, I will go upward a little bit. I want to flip it again. I want to change the direction to reverse it. What reverse does is it is going in the other way. So there are some things that are conflicting. That's why you're not seeing anything here. So if it's going in the other way now, that means if I'm offsetting it, like I said, if I'm offsetting it by 200 millimeter, no, by 40 millimeter in the other way, it's not going to be possible. But if I increase it to 400 millimeter now, it's possible. You actually see something to show you that it is working. 400 millimeter. I see. I can see something now. So it is telling me that initially I was going in this direction and I decided to change it back. That means this reverse is affecting the normal direction of the extrusion. Do you get what I'm trying to say? It's affecting the normal direction of the extrusion. I'm not extruding it downward again, I'm extruding it upward. I want to reduce it back to 50 millimeter. I'm not reversing the offset. I reverse the direction of the extrusion. It's different from reversing the direction of the offset. So I'm reversing it back. You see, after I reverse it now, it is the same thing 50 millimeter like I said before. Once you reverse the offset, do you know what it does? It actually goes above that surface by 50 millimeter. It goes above the surface by 50 millimeter. It reverse the offset. And if you don't reverse it like it was before, it will go above it. It will be 50 millimeter before that surface. I'm reversing the offset again. I'm checking it. Can you see? If it's not going up to it again, I can actually use it to 40 millimeter. explain this extruded boss because that's a lot of options. And as long as you know how everything works, that's the most important thing. And it's important that it increases. And it's important that increases like that. So when you see back, and then when there's difference between reversing the direction of offset and reversing the direction of extrusion. What I'm doing is reversing the direction of extrusion and it's not meant to be so. I don't know what to reverse the direction of extrusion because I'm initially going in this way and the surface I'm dealing with is here. So I'm not going to the other side when there's no surface there. I'm passing the extrusion from here, from this side. I already did an offset from here and I'm going to here and I'm doing offset from surface like 40 millimeters from this face. So I'm reversing the offset again to show you. Can you see? So that brings us to multi-body part, another concept in design. So what multi-body parts means is, I said you have assembly, you have parts, you have assembly. Assembly, what assembly just does is they are merging different parts together. You assemble it using some mates. They are called mates to define their condition, the way they interact with each other. It's like you are coupling something with a fastener. You are coupling it. So, or maybe you are working it. You are joining something together. You are joining different parts together. That's what assembly means. But you can actually make a part, normally a part model that you are designing here. You can actually make it look like, that's why they call it multi-body part. It works in part modeling. Rather than make one single part have like 3 bodies. Now, what multi-body part means is, as I'm doing this extrusion now, telling me here, it is automatically checking this match result for me. What match result does is it ensures that this second extrusion I'm doing is actually matched together with the first extrusion I did, so that they are treated like one single part. They are treated like a single body. So if I check it now, telling me that they are no more a single body. They are like multi-body parts. They are a multi-body part now. That means a part that has different numbers of body, like more than one number of body. That's what multi-body part means. So after I will see this merge results, merge is like when you are merging something together. So I will check this. So I'm telling it that don't merge the results together for me. What this selected contour now means is that it's automatically selecting this sketch for me. Let's assume I don't want to select this sketch. There are scenarios whereby you draw multiple sketches and you just want to use maybe some inner part of that sketch there. So this is where you do it. You uncheck everything. So it will have checked everything for you before. So you uncheck everything and start choosing which one do I want to choose here. So I'm automatically choosing this one. Can you see? It is very this part. And what the student board does is you can extrude a sketch that has open loop, like it is not closed, and you want to extrude it is not possible. I will show you that scenario too. So this multiple body parts now, I will use this ability to explain it. So don't do this extrude now. Can you see? It's taking this two body as two different as a part with two different bodies. So this is where you know that it's a part with two different bodies. This part here, solid bodies. If you click on it here, you will see the first body and the second body. Can you see? That's the difference. And another thing you know is that you notice that those the two parts are not like matched together. But you notice the difference of the lines here. So you notice that this line, there are lines here around here. There are some lines that split it together. But if I go ahead and exit it, this extruded boss, I want to merge the results together. So I'm merging it now. How is there a difference? Like there's a particular difference between the two. There's a difference between the two. Okay, if you are unable to see any difference in the body now, can you notice that the solid body has actually reduced to one? If I can click on my Control Z to go back, Control Z to go back once again. So when it was two bodies, which is I can apply different material to each body. Which is what multi-body part does is if I'm designing a part now, maybe I'm designing something like how will I describe it? Let's say I'm designing a part like let's say I'm designing a part like electric motor now. And I want to design it just like a part. I don't want to split it, design the components one by one, start planning together. So I actually split some part there and apply different material to each part just to show that that's what the multi-body part helps with is it does help by helping to apply different material to each part. So the electric motor will be made of some areas. It won't just be made of one particular material throughout different materials. Maybe you work on it with a simulation, you want to do a simulation on it. So if you are applying the material, you are actually specifying that maybe this part of the material now of the part you designed is going to be steel, this one will be cast iron, this one will be this thing like that. So how to make this inner part material that this inner part is going to be so how to edit the material. I'll click on edit material here. I want to show you what multi-body part does. That is just a simple concept of multi-body part. It's where you are applying all those features, you will see an option here that shows you that you need to merge results. Or you can try to manage the results, you are actually attaching it to the part. Or if you are not managing it, if you are checking the merge, it is usually behaving like a single part with no bodies more than one. It is just one body. So I can apply plain carbon steel here as the material. Let's apply the material here. For the first part, I'm applying plain carbon steel. So I'm closing this dialog box. Can you notice that the color
You
changes?
can't see your screen again, sir.
Okay, you can see it again. Okay, let me go back. Is the network just notify me once you can't see my screen? So I have to reconnect again.
Sir. Sir, but the call will end in the next 1 minute. Why not Kuku create a new
Okay, let me
Google Meet
new
link
one
like
now.
that?
So that's fine. Let me click the new one. Let me put this call. So I'm putting it now. X Y Y X X. balik nínú yẹn balik bos kẹ́yìn ni ó sì dẹ̀ ló ti bára wa ṣe. BMC BMC Can you not hear me now? So I'm going to share my screen once
Yes,
again.
sir.
Okay, I'm sharing my screen once again. So you get the concept of multi-body parts. You are only just explaining it. So what? Can you see my screen now?
Yes, sir.
Okay. The second person on the call, can you see my screen? And that person turn on his or her mic. Can you see my screen? So, like I said, I'll be explaining. I wish the person is not talking. Maybe they don't join the call and ignore everything. So, like I said before, most multi-body parts mean is just that you are designing a part. Maybe that part is made up of different materials. For example, now, let's say you are designing something like a plug that connects to the wall, like a plug now. You know that the edge, the mouth is not plastic like the body. So the outer body, everything is plastic. But the edge is, I know that you, if you want to use that particular part for a particular simulation, that has to be involved with the material you are going to apply. So you know by just designing everything and matching everything together and making it a single body does not help. And designing it as different patterns starts assembling it, so it's not something easy. Because there's something called when you are moving something now, you need to take note of what you are doing. Like designing different, so let's say you are designing things that you can actually design this in one part and you are splitting it into different assemblies and making an assembly file. It actually takes a lot on your system computing power because it takes more when you start defining it, relationships, all those things, you start calculating everything. So it takes more on it. So instead of doing that, I decided that thing on just one part and there's a way to call multiple parts. And when you are doing some extrusions or removals, all those methods you are applying like that, those functions you are applying, you can just there's an option there, okay, we always need that option there. Extrusion is not just fusion tools. Split boss, board boss, split boss, not split boss, boundary boss. There is no split, it's always there. So where you can just check it, that is you are not matching the results. So if you don't check it, like you are not matching it, it's automatically after you check it, it will split it into two. Like I did here, I will check that my results. So you guys see here, I will check my results. So I will check my results. So once it goes through all this, so I now show you guys I don't want to apply different material. This is not part of what you are doing today, but I don't want to apply the material here. I applied plain carbon steel here. Let me apply plain carbon steel here. So I apply plain carbon steel here. Let me apply another material in the outer part. Then I'm applying the plastic material now. So different materials here, we have plastic. Then I want to apply there is no that realistic. There are a lot of plastic here. I don't even know what they are used for. Let me just apply just one of the let's apply this PP film. I'm applying it now. I'll close it. That actually has to do with the material, the mass of the proper of the pattern. So the mass of this changes. I see the preview of it changes like show you that it's in real life. This is how the material looks in real life. It is making it worse. It shows that this is how the material looks practically when you see it. So you don't really know how the carbon steel looks like. But I say it here, that's how it exactly looks like. I don't know if others of it has that too, but that's how this looks like. So that's what multi-body part does. That's just to show us what multi-body part does. So normally, as long as it's not a multi-body part, you don't want to apply the material generally to everything. You can just click here and edit the material and apply it generally. But it's a multi-body part, and that's the middle aim of multi-body part. You want to apply different materials to a single part. A single part can be made up of different sections of things. So everything is not just one material. So that's what it does. Multi-body part does. So I want to edit this picture once again. I'm editing it once again. So I'm editing it once again to show you guys. Like I said, you can manage the result like you can manage it. So I'm managing it now. Managing it here and I'm choosing it. I've explained out of all these options, blind and I've explained blind. So what true does is what true does is it does exclude that thing like it takes it keeps it going through all. It takes it through of everything. That's what true does. But for this up to body, just like up to surface, it takes it to a particular surface. For the up to vertex, it requires a particular kind of situation. I'll send this next to the group for you guys now. After sending the sketch to the group, I will actually design it now and show you guys just something, some little things of. I'll send the sketch to the group now. I want to look for the sketch here. Okay, just to explain it. And I've explained graph before, so I've finished usually on this extruded boss part. For those that require special scenario, mostly what you'll be doing on this 3D modeling part is I'm not really spending much time on these tools just to show us what everything does. So after showing us, what we'll be doing usually is I will be doing some sketches on it and showing you how to do like the modeling thing of it, the modeling of the thing. So I will show you how to do it. Through that, I think I'll be able to explain the other options too. I think that one is better because start creating a scenario for each option kind of looks tiring. So I have to think of what kind of geometry will I draw to create that scenario for you guys. So it's kind of look tiring. So I have to create another thing. So let's just manage the time. Finish this what we just did now. So I'll go through my file here and see if I can see this case. Yes, this is what I'm going to. So I was cases here now. This practice problem, this one. I'll start dropping some of this on the group, like a lot. And I want you guys to be doing it and let me see what you can do on it. I'm glad to open this PDF now. I don't know why it's not. It's not even opening. So by the time it opens, I want to explain sketchblock for you guys. Let me explain sketchblock. Sketchblock is very important. because my system is low and I'm learning a lot of things here. So everything just seems fine. So trying to I'm trying to yeah, like why this is for I hope you all see my screen. I lost my screen.
I can see it, sir. I can see it.
I hear me. I just want to confirm.
Yes, sir. You can see the screen.
Okay. I'm trying to do this sketch. So I have to delete this picture now and let's sketch block. Not be able to take before both today, but at least even if it's a straight board that we're able to pick, should at least know something on the extruded boss before moving ahead to another thing. So I'm sketching now to explain the sketch block. Everything is so I'm sketching on the top plane now. I want to draw to demonstrate sketch block. So I also explain sketch block first before demonstrating it. What sketch block does is it's just meant to maybe you want to do a particular assembly. What it tells you to do before setting yourself and going to 3D model to help you visualize the assembly and move it and make them relate and make it move. Something like that. So I will show you guys now. Let us now draw a rectangle here. Let's say a corner rectangle. The dimension now The dimension of 50 millimeter is showing 1.6 something. The dimension of 50 millimeter. Because my system is low, almost dead. So that's why it is not running perfectly. And there is no light here, so I'm just trying to keep up. I don't want to see if I can just explain the sketch block. Which is the major thing that will help you guys is I will find a lot of materials for you guys that will those that just go deep that will be helping you guys along. So as I'm explaining in class, you will understand with some materials. So 50 and I'm doing a boss like is it in straight slots? Yeah, I'm doing something like a straight slots. And I'm doing it like this, something like this. What I want to show you is how those things move in relation to each other. Nothing special. So I'm making this coincident with I'm making this coincident with the origin. That's it. I'm clicking on this. And I'm making horizontal or coincident with the origin. That's another thing. So I can just make after doing these things I'm doing. All I have to do is I have to make each sketch block. So that's how sketch block works. So after highlighting all the sketch, so it's supposed to show me like make it sketch block. So I'm making it a sketch block now. It's taking a lot of time to run. So sorry for I'm making it a sketch block now. I want to show you guys this sketch block at least. It's very important so you see how sketch block works. So I have to make this to a sketch block. Why is this showing? Okay, I'm making this one to a sketch block. I'm like clicking after highlighting it, I'll right click it. I'm making the sketch block too. This A here is one sketch block. Yes. So I'm making the sketch block down. I'm clicking on OK here. So I'm highlighting these two. So I'm making it this, I'm right clicking on it. Immediately you highlight it to bring a notification. So you can choose from the option here. So I'm making it a scale block. This A. So I'm making it a scale block. It means I'm making it a scale block. So I can just click on it here. So let me click on my control here. So I'm clicking on control here. So I can go ahead with, I want to make some changes here. I'm exiting the sketch. I have defined some sketch relations before making everything a sketch block. So sorry that my system is taking a lot of time to load because I've done something on it, so it's up. Let me find it out to demonstrate the sketch block so you guys know. I hope I'm not disappointing you guys.
Not at all, sir.
Very sorry, system was strong like that. So, okay, I want to delete the sketch first and do it the proper way. So I'm clicking on the sketch back once again, clicking on the sketch. So I'm doing it on the front plane. So I'm doing it on the front plane. Okay, so I'm clicking on rectangle. So I want to make this 250. Oh, my system is spinning right now. Okay, okay, okay. So I'm making this one 250. It's currently low, almost dead. Now what we are going to do, maybe we should just stop here because the way my system is doing. We need to just stop here because I'm not even able to do anything. It's too slow. It's too slow. Can you hear me? Can you hear me now? And the next
Yes, sir.
slow.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
If you just stop here, I promise this we've done Extruded Boss now. So if this like something that you guys don't understand, I'm really recording. So I will stop with the recording as usual to our YouTube video and I'll post the link on the group. So you can just go on that Extruded Boss. We will not be able to finish the whole boss today because I want to explain different scenarios for the extruded boss. I don't want to see the normal basic extruded boss. I want us to know everything. So that's why we're not able to finish it today because that different scenario and I want us to know it very well. But the best way to know it is that I will look for like skills and build model that something I've practiced before. I'll bring it to the class, practice it and show us like that we encompass everything, how I'm using everything. So that one is better that way. But after the class now, I will drop some simple like PDF on just simple small extruded boss 3D model. I can just do as let's say assignments and I must sit down. So I won't forget it. The one you send to me, I'll check it. I'll check the assignment you sent to me. I'm very busy. That's why I didn't have time to check it. So I'll check it. So and if you don't if I sent this assignment now, after this class, I'll send the assignment for today. So you guys send it to my DM. The number I dropped on the group, send it to me for any assignment. I'll not pick the number now. So send it to me for assignment. So just send it to me. I'll check it personally. So due to the my schedule today, so we have to stop the class here today. So sorry. That's okay. I will the first thing I'll do next class. Even if I forgot it, please try to remember. We need to do I will explain and start sketch block. I will explain it the first thing. I'm supposed to have explained the two sketch that I did last week. Because it's a sketch. So I'm supposed to have explained what we explained before we do anything on 3D next class. I'll explain the sketch block. So I will drop the assignment after the class. Not something complex, only I can just use your student boss and every other thing. I can just use it to do it. That's all. So that's all for today. Have a nice day, everyone. So I'll do the recording. Maybe like tomorrow morning,
Okay,
I'll
thank
start
you.
the recording. Okay.
Sir,